Cast your mind back to our section on linear approximation and quadratic approximation. We would start out with a cosine graph looking something like this. And then with a linear approximation, it gave us a straight line like this. A quadratic approximation would give us something like this. It would give us something like this. So the way we did it was that we start out with a cosine graph. We would start out with a cosine graph, and our job is to come up with A, B, and C in such a way that this thing here will come as close as possible to the cosine graph. And the way we did it was to ensure that the first derivative of this to be the same as the first derivative of this, and that the second derivative of this matches up with the second derivative of this. So what we would do is we don't know A, B, and C, so we would start out with this, differentiate this, that will then give us this, and then differentiate it again, that will then give us this. And then for our cosine graph, do the same, differentiate it, it will then give us minus sine x, differentiate it again, will give us minus cosine x. So our job here is to find A, B, and C. So we would ensure that the second derivative of the cosine graph to match up with the second derivative of this. So at x equals 0 at this point here, the second derivative, well, you would put the 0 into here. So that means the second derivative will be the second. Well, put 0 into here. This would be 1, negative 1. So the second derivative will be negative 1. So to find A here, we would put negative 1 into here. So now to obtain A, we would divide both sides by 2. So A equals negative a half. So now we know that our coefficient here is negative a half. And then to find B, we would make sure that the first derivative of this matches up with the first derivative of this. So at x equals 0, we would put this into here. So sine of 0 will be 0, negative 0 is 0. So ensure that this equals 0. So at x equals 0, put this into here. This thing disappears. So b equals 0. So now we know that A equals negative a half, B equals 0, so we can pretty much ignore this. Now to find C, we would ensure that this matches up with this. So to find C, well, at x equals 0, we would put this into here, and then this whole thing here will become 1. So f of x when x equals 0 is 1. So make this to be 1. And then at x equals 0, put this into here. So this whole thing here will be 0. Put this into here. This whole thing here will be 0. C equals 1. So now we know that this equals negative a half. B equals 0. So we can ignore this. C equals 1. So now we know that well, if you get a graph, if you get a graph plot f of x equals negative a half x squared, and then plus 1. That will then give you this blue line here. So it's a very good approximation. So the weird thing is that you could continue on with this process. So you could, instead of doing a quadratic with just x squared, x, and a constant, you can continue to infinity. So you could look at let's say x to the power 3, x to the power 4, so x to the power 5, x to the power 6, and so on. You can create your function all the way to infinity. So earlier we only looked at up to x squared. You could go all the way to infinity. I will continue in the next video.